Okay, and here we get to the scientific method, and this will be my last slide for this lecture. Okay. So I'm just going to give you a very brief overview of this. Okay. And I think this is really important, especially in this world that we live in now where science is being like almost attacked, right? There's a lot of science deniers out there in the world. So I think it's especially important to understand how we go about the scientific process. Okay, so it starts with observing some natural phenomenon. We see some amazing looking dots in the sky at night, and we have no idea what they are. So we propose a tentative explanation. What if they're giant balls of gas burning hot 1 billion miles away? That would be a hypothesis. So then we have to generate some predictions to test that hypothesis. And I started off with a really terrible example, right? Because some of the early people, right, the first people to observe the stars, man, that must have been tough coming up with those hypotheses. But one of them might be, oh, I see the stars move each day. They change positions just slightly. Okay. So then now, how do we test that hypothesis? Oh, well then a test for that hypothesis might be, okay, on this day next year, they should be in the same position. So we'd have to design that experiment. Okay, I have to wait a year. I have to stand exactly here. I have to look exactly in the same position that I did. And then I'm going to take results. I'm going to analyze those results. And if I didn't see what I thought should happen, I have to either go back and reject the hypothesis, or I have to modify the hypothesis, or I can just continue to test and make more observations. So science spins, oh, excuse me, I misspoke. So when I'm analyzing the results, right, I'm kind of going round and round in this area. And then once I finally have accepted the hypothesis, I reach out to my peers and have them kind of go through this, okay? So science is a constant going round and round and round. We often talk about competition in science, or outbidding somebody for a grant or something like that. But I want to be very clear. I think science is one of the most collaborative things out there. We wouldn't be where we are today if we didn't share our results and modify our hypotheses as a result of sharing results with other scientists. Perhaps another scientist was able to observe something much better than we were originally. So we don't want to reject them because they did something better than us. We want to praise them that they did something better than us. We want to keep building this up, keep going round and building it up each time we go round and round. So I think that communicating with other scientists, being collegial, being collaborative, being helpful to each other is extremely useful, and it's what moves science forward. Okay, so I think on the next slide, we're going to start getting into units and calculations. So I'm going to pick up from here in the next lecture. Okay, so thanks for watching, and stay tuned for the next one. Hasta luego.